Okay, this video is going to introduce the hypergeometric distribution. This is a discrete distribution, and it is one that is useful in many different contexts, and so it has sort of been given its own special name. So this is going to, first of all, I'm going to describe when we can use it, show how we can find probabilities associated with this distribution, and then we'll do a quick example. So suppose we have n objects, capital N, and that there are two different types. N1 are of type 1, and N2 of the objects are of type 2, such that the total number of objects is the sum of N1 and N2. So each object is of one type or the other. If we select n of the capital N objects, so little n is the size of the group that we're going to select, and we select them without replacement, then we're going to let x be the number of the n selected objects that are of type 1. We can see that because we would be randomly selecting objects, this is random and it's a numerical outcome, so it's a random variable. It's discrete because it can only take on specific values, not an interval. For instance, I can see that if I'm going to select n objects out of n, there are a couple things I need. I need to have n, the number I'm selecting has to be less than or equal to the total number of objects. Can't select more objects than I have. There are a couple of other things that we notice. If I'm interested in a specific value, little x, so I want to find sort of f of x, which is the probability that x takes on a specific value, little x, that this is going to be 0 unless my x is less than n, right? I can't have more objects of type 1 than I have total objects that I've selected. I can also see that n minus x, which is the number of objects of type 2 that I'm going to end up with out of this group, because if x of them are of type 1 and I have n objects, n minus x of them must be of type 2, this is going to have to be less than or equal to n2. And of course, I also can't select more than I have of type n1. So I also am going to have the condition that x has to be less than or equal to n1. So I have all these sort of conditions, and these are defining where the support will be. Now suppose I want to find the probability that x takes on a particular value. The way I'm going to do it is I'm going to be using classical probability, which remember means that I've got equally likely outcomes. I'm selecting at random, so I'm equally likely to choose each object. I'm going to count the total number of ways that I could choose little n out of the n objects, and then figure out what proportion of those ways would involve having little x of them be type 1 and n minus little x of them be type 2. So the number of ways that I could choose little n out of the n objects is n, choose little n. The number of ways that I could have x of them be of type 1 I'm going to have n1 total that I could choose from of that type, and I'm choosing x of them. And then the number of ways I could have the remaining n minus x be of type 2. I have n2 that I can choose n minus x from. So this is going to be my probability mass function for my hypergeometric distribution. Quick example. A classroom has 19 students, of which 10 are girls and 9 are boys. If 11 students are randomly selected to be in a reading group, I'm going to let x be the number of girls who end up being selected. Notice a couple things. First of all, we can see that x is the number of girls selected. I can see I've got my number that I'm picking, my little n, is 11, right? But there are only 10 girls in the class, so the number of girls can't be more than 10, so x has to be less than or equal to 10. Notice also that since there are only 9 boys, I couldn't have no girls selected, right? Because then I wouldn't have enough boys to fill up the group of 11. So I also know that x has to be greater than or equal to 2, right? Because if I had all the boys in there, I'd still need to have 2 girls to get a group of 11. So when I'm thinking about the support of x, the support of x is going to be the integers from 2 up to 10. And just thinking about this in terms of the notation I talked about before, n is the total number of objects, in this case students, so that's 19. n1 is the number of type 1. Since I'm interested in girls, we'll make type 1 be the girls. There are 10 of them. n2 is the type of the number of the other type. The other type are the boys. There are 9 of them. I already said that n, the number I'm selecting, is 11. And so if I want to find my probability mass function, f of x, which is going to give me the probability that the number of girls selected takes on the value little x, it's going to be, I've got 10 girls from which I'm choosing x of them. I have 9 boys from which I'm choosing the others that will make up the 11, so 11 minus x of them, divided by the total number of ways I can choose 11 from the 19. And again, this is for x that's in the support that I defined up above. So if I want to find the probability of choosing 6 girls, I can do that by taking f of 6, which will give me 10, choose 6, 9, choose 5, divided by 19, choose 11. And I can calculate the probability that way. If I wanted to find the probability that I choose at least 3 girls, I could do this by finding f of 3 plus f of 4 plus f of 5 plus f of 6 plus f of 7 plus f of 8 plus f of 9 plus f of 10. You can see that this is going to get quite computationally busy as we do all these calculations. I just wanted to point out that in a situation where you're looking for the chance of a value taking on something larger than something else, greater than or equal to 3, a lot of times it's easier to work with the complement instead. probability that x is greater than or equal to 3 is the same as 1 minus the probability of the complement that x is less than 3. The only value of x that's less than 3 is 2, so that would be 1 minus f of 2. And that would be a much easier way to do the calculation. Than doing substitution for all of these different values. So hopefully this little introduction to the hypergeometric distribution helps you get started working with it. There are a few problems in the homework to get started, and if you have any questions, please let me know.